Hopefully everyone can hear me. Really excited to talk to everyone today. This is basically the first video in a set of webinars or demo sessions that we're going to be doing throughout the month of June on CAD and jewelry design, trying to get people into kind of one of the hardest parts of sort of the digital creation workflow, which is actually CAD. Um, you know, Formlabs enables people to take their designs from the computer to real life, but I think we really want to acknowledge that there's a lot that people need help with the CAD side. So I'm here today to show you one of the pieces of software that I'm familiar with, and I think it's really interesting piece of software. It's Blender 3D, and Blender is basically a free CAD package. What makes it kind of unique is that it's actually incredibly fully featured and powerful compared to standard industry tools. If you think about jewelry CAD, you might be thinking of Rhino or Matrix, Jewel CAD software like that. But Blender is this totally free open source software. So from the just cost perspective, it has a really low barrier to entry. And it actually has really active development behind it. It's partially funded by Google. And it's used in a lot of professional settings, just kind of on the merits of its capabilities. So yeah, we really just wanted to give you kind of a cross-sectional slice of the world of CAD this month, to help you understand, what the different offerings are out there for jewelers, designers, jewelry businesses, and more importantly, just help you make a decision of what kind of CAD software you might want to invest your time and effort to learn, and to get into one of these tools. So actually on this month we have on deck, today, which is I'll be talking about Blender. Then we'll be doing a session on Rhino. Then later down the line, Tinkercad, ZBrush, and Free Design. So we're kind of covering a pretty wide gamut in terms of what's available. So yeah, let's dive in. I just wanted to leave the floor open if anyone wants to ask questions throughout the demo. Feel free. I'd love to interact with you guys and find out if you have basically either issues that you've run into in your design process or specific things that you're working through how to create. Maybe I can help you if you can send even a picture of a sketch. I'll put my email address right in the chat box. So if you want to send a cell phone image of what you're doing, that could be a really cool way to just start a discussion at the end. So yeah, I'll do that right now. Let's see. So that's my email, and feel free to send me what you're interested in trying to do. Yeah, let's just dive in right now. Let's see, and if you let's see if you have a I guess one thing I'd love to just get a sense of right here at the beginning, if you feel comfortable doing so, I'd love to get a sense of where people are in CAD, just so I kind of know what kind of audience I'm talking to and where I should focus. If you wanna put in what you're currently using or try to use, and generally what your skill level is. Experiencing Ryan, cool. So yeah, I'll just share my screen here and get started. This is the Blender interface. So Blender, there's actually two kind of versions out there right now, Blender 2.79 and Blender 2.8. We're showing Blender 2.7, mostly because one, that's what I'm most familiar with. It's kind of been around for a long time. There are a lot of great extensions and tools available for it. 2.8 is really awesome. It has a lot of kind of upgrades in terms of the interface. I won't go too much into like how to use the specific interface today. I'll try to talk through what I'm doing in a more general sense. Yeah, if you want to get started, you can use 2.8 or 2.7, but they're relatively similar in how they operate. Let's see, I think we got one more answer here. Experience in 3D design, interested in CAD. Have a basic understanding of sculpting. Yeah, so it seems like we have a couple of people who come from the Rhino world and the 3D design world, which is definitely it's not totally far off from what you do in Blender. So yeah, let's take it forward. So I think the really first question you want to ask yourself when approaching modeling something is what kind of shape is it? So this is kind of a rudimentary question, but like I really want to know, what kind of shape is the design that I'm creating, and it, from that it follows like a few different questions. So I'll actually share a little sort of flow chart I made. I'm going to do it in Blender here. Image editor, open, shape map. So this is kind of a map of what kind of shapes that people typically create in CAD. It doesn't cover everything, obviously, but I find it to be kind of a helpful breakdown for deciding how you want to approach starting a design. So in one sort of in one path up here we have kind of what I call rectilinear shapes. So it's kind of geometric, angular. Basically, in these types of shapes, really what's driving the design is the relationship between different parts of the model within the model itself. Curvilinear designs are, basically designs that are mainly have sort of compound curvature. Does the design have hard edges? So hard edges are obviously part of rectilinear designs and curvilinear. Hard edges can be sort of a curvilinear design typically does have hard edges, usually not completely smooth. But this would actually use a sort of different design methodology or different CAD methodology than something like a sculptural design. And so each one of these paths requires a different sort of part of the program in terms of Blender or different CAD software. So if you're coming from something like Rhino, I think Rhino is really where it stands out is in this kind of, it's actually started as an architecture design program. So it really stands out for this kind of rectilinear design, and then with NURBS or like curve lofting, that sort of gives you the ability to do hard edge tools. And then in the more advanced versions of Rhino, where you have jewelry specific added functionality, then you start getting into something that I call referential, where you have a design and it's basically referencing real world objects that you need to create a model that has precise dimensions that references it. Sculptural designs, this is where you end up in the realm of something like ZBrush. It's also covered by Blender, which is really awesome. So anyway, this is just kind of an interesting map that I wanted to show you guys, but we might sort of come back to it. All right, so I think what Blender is really great at is what's called constructive subdivision surface modeling. So this is where you're creating shapes that are basically defined by a smooth skeleton. So I'll give you a sort of example of what I mean by that. So this is what Blender looks like as you sort of enter it, essentially. I really recommend, if you're using Blender, to have a keyboard with a number pad. When you see me sort of shift around to different views like this, it's just directions on the number pad, and it gives you different views. So subdivision modeling is essentially where you start with a skeleton of a design. So we'll take this cube and enable subdivision modeling, which is in the modifiers panel here on the right. Basically, in the center view, we have the 3D view, and on the right, we have sort of what's called the modifier stack. So this is kind of alterations to the model that are not necessarily applied in a permanent way, but they can be stacked on top of one another to create different adjustments to the shape of the model. So subdivision surface is a really core one for any kind of, especially jewelry modeling, any kind of modeling with smooth shapes. And what it will do is it will smooth out the shape of the model. So a cube turns into a sphere, basically, and you can increase the number of levels to create a smoother sphere. And then from that, you can basically take parts of the model, and essentially the shape is driven by this outer skeleton. And so you're adjusting a fairly simple form, but you're creating something underneath that's much smoother and has much more detail, in fact. You can click this button right here, which lets the sort of the editable cage of that subdivision model just sort of wrap to the model, which is really useful. You just want to kind of click points on the model, drag them around, and suddenly you have the ability to create kind of very dynamic flowing shapes very, very easily. If you're coming from something like Rhino, to some extent, this is similar to what you'd be doing with curves and NURBS modeling. It has a lot of similarities. It's not exactly the same in how it works. I think the key difference is how you start to control the shape with edges. So in subdivision surface modeling, let's say we have this shape. I've just made this random shape, but we can start to take edges and define them as having more or less sharpness. So we could take this edge and give it a little bit of sharpness, and suddenly it has sort of reverts back to its sharp shape. So this is obviously a not interesting model, but I can show you. Let's take something like a circle, sort of the fundamental or archetypal shape for many rings. Units in Blender are called Blender units, but they're actually millimeters. So if you export from Blender, you're going to get a millimeter scaled object. So I created a circle, and how I did that is just by pressing space. If you're coming from Rhino, it's actually really useful to know clicking space gives you the ability to search for something. So if you have a general sense of what you want to do in terms of like adding an object, adding a circle, you just type in circle, and then you would say add circle, basically, and that's what I just did. So we have a context menu here that gives that ability to just add sort of presets, but you can also just search for things in a similar way to Rhino. So let's say we have this this ring. We want to give it a little bit of shape, so we kind of extruded it. So that's basically pressing E and then moving it over, and then let's just extrude that entire ring. So we're taking the surface of the ring and extruding it. Now, when we extrude region like this, what I'm doing is I'm basically extruding the region and then right-clicking. That sort of zeroes out any further effect. So if I just extruded and then moved it, it would do some kind of weird extrude along some axis. But I'm just right-clicking, and then it sort of keeps it in the same position. And then you can press Alt-S, and that gives it a little bit of scaling, or it's called shrink fatten over here on the left. And you can see what kind of offset you want to give it. So let's give that a 1 or let's say a 1 millimeter offset, -1. It looks like we made a ring that's actually rather small. And so we have this ring, and it's defined by, if I turn off the subdivision smoothing, it's sort of this chunky, blocky ring. I turn back on the subdivision, and now we have this smooth, nice ring. And then let's say I want to give it a few sharp edges. We can select loops around the edge here. You can do that in Blender by pressing Alt, Shift, and then right-clicking. That selects kind of a topological edge along the surface. And then just giving it a crease. So that's over here in this right panel. We're giving it a crease, and suddenly we have this kind of nice edge. And I want to make this just a little bit thinner, so let's just give it a little nice. And so now we have a very simple band, similar to what I'm wearing, and that's lovely. And so this is kind of a very, very basic kind of description of how modeling works in Blender. Taking edges or surfaces or points, extruding them, moving them with your very typical sort of translation gizmo here. Often, if you want to make kind of sort of dimensionally accurate movements, so let's say I want to give this ring just a sort of like a flat top surface. So I'll extrude that and then take the scaling and just scale that whole surface to 0. So now that surface has been scaled to 0, but it was scaled to 0 on its kind of midpoint. So we'll take that, just move it up, and it has kind of an interesting curvature. You might like that or you might not. I don't love it, so I'm gonna just make that top edge here, which is kind of a topological ring called an edge loop, and I'm just gonna make that pretty sharp. And now I have this nice sort of rectangular shape. Another way you can sort of manipulate subdivision meshes is, let's say, removing that crease there, is just by adding another edge loop. So I did Control R and just added another edge loop. What that does is something very similar. So that's almost effectively the same as giving it a crease. It's just giving it an edge loop. And if we turn off the subdivision, you can see that edge loop is actually at the same position as that other ring. So we remove the shell, you can see just making that edge get closer gives it a sort of sharp edge. So those are sort of a description of how subdivision works. It's a really powerful tool. It's kind of an industry standard for how this kind of CAD software works. And Blender really follows all of the normal conventions for subdivision modeling in terms of how edge loops work and how they interact with other functions. Like, for example, if you want to give something a bevel, you could select these edges and just add a bevel. Let's actually define them as having a bevel first. So we've taken these edges and just gone over here to edge data and just given them a bevel. And that's just defining them as having a bevel. And then we'll go to here in the modifiers, which is this non-destructive way of adding functionality or adding adjustments to the model. And then we'll just tell Blender that we want to give it a bevel where we added the bevel definition, which is called a bevel weight. That's right here. And we'll move that up in the stack. So that bevel actually happens first before the subdivision here. And now we have a bevel, and it's also smooth in the same way that the rest of the model is smooth. And that bevel can be adjusted in terms of its radius. You can add more segments to make it smooth. So that's a very, very simple example. I'll go into some more complex examples next. Cool. Yeah, let's take a look at some designs that we've already designed, sort of cooking show style. Just look at them and try to understand how they would be created in Blender. if you have any questions about what I've already asked, please just put them in the chat. Happy to. I know I'm sort of blasting through in terms of the interface. You know, maybe unclear how exactly I'm manipulating things. So I'm happy to, you know, explain exactly what I'm doing if you need or are curious. I'll also at the end just give a couple of nice tutorials that I like that are that talk about basically Blender interface basics, and those are a really good place to go if you just want to like figure out how to manipulate the program. So yeah, let's go into. So actually, I don't know if you can see. Yeah, I think you can still see me. So I made this quick sketch of a flower. So it's actually planned to be an earring. And so I took a photo of that, imported it to my desktop. Let's just, I'm going over here to the top and reloading the starter file, and that makes a new model. Just clears what I was doing before. And I'll just go and import or go to the image editor. So this view panel here can be all sorts of different things. It can be a 3D editor, it can be an image editor, it can be a text editor if you want. It has a lot of different optional functionality. Let's see, we have a couple of questions. Are there any presets that can create basic forms, i.e. ring sizes, just via creation? Yeah, so let's see. I think that's a really good question. And basically Blender mostly is what's called kind of what I describe as like an explicit modeler. So it basically doesn't have very many sort of presets. You know, if you're making a ring size and you know that diameter, you can very quickly make a ring like I just showed you. You can also do things like, you know, let's say you want to just add a very basic ring. I'm going to add a mesh, add a torus. So this is not, you know, exactly a ring. It's, you know, a mathematical torus shape. But what this will do is it'll show you, you know, you can change basically over here on the left, the major and minor dimensions or interior, exterior dimensions. And this is going to give you the total exterior radius of the torus and the total interior radius of the torus. So let's say I want a 20 millimeter, you know, ring size, in interior diameter ring size. I would take this and I would make it 10 because it's radius. That's actually going to get quite large. And then the exterior, let's make it 11. Exterior radius. Yeah, so that's just changing that. So those, if you go to add objects, you'll see all of these kind of preset shapes, and they're sort of basic fundamental shapes that you can play around with. But to your question, I guess, Blender does not have built-in, for example, like presets for like jewelry-specific features, like prongs or, you know, stone holes. So those need to be defined manually. And what I've done, and what I think a lot of people tend to do, is, you know, basically create a personal library of common shapes that you use. So let's say we want to add stone holes to a ring like this. Let's just make it into an actual ring rather than just a torus. I'm just scaling this on the Z to give it some width here. Again, we're going to enable the subdivision. Oops, not subdivision surface. Now it's just more of an actual ring. I'm going to get rid of some of these edge loops. Move this in. And lift this, please. So if you wanted to make, let's say, a set of stone holes around the edge, you could create sort of a primitive object that's a stone hole. So it's not called a stone hole in the program, but you know that it's a stone hole. And that's going to be defined by a cylinder. And the cylinder, we're going to just sort of punch it out of the ring along its band. So let's move this up to the top here. Actually, it's not the top; it's sort of on the side. I like to have the whole ring oriented, sort of like vertical. Just helps me sort of rotate around it because it rotates on those D. So we're going to punch these out of the ring sort of around the band. Make this more of a typical shape. So Blender has in this kind of modifier area typical Boolean operations, which are where you can union or join or subtract one object from another. So we're going to take a difference and just subtract this object from the other object. And now we have make this wireframe mode. Now it'll show that this is hidden. And you can just take that. This cylinder we know is in the dimensions panel here. It's 2 millimeters in diameter. We could take this cylinder, make its origin around the center, and then let's just give it an array. An array is kind of well, you guys know what an array is. It's gonna sort of repeat in a pattern, and then let's give this a empty object. So an empty object is an object with no geometry. It just helps you define rotations or movement. And we're going to link this object to the empty. And actually, let's just link its object offset to the empty. And now when I same location. Some people are asking questions. Let's see what you guys are saying. So what it did is it's creating, these are actually different scales. So it's just one scale. There we go. Now, when I rotate this empty, it's going to make an array. So let's just times. And suddenly we have a set of apply these and do other operations. So, just some technical difficulty. Blender, for some reason, doesn't like doing lots of booleans in the same space for some reason. It can be a bit tricky to navigate. Right, let's roll past that. Sharing is pause. One screen sharing pause. All right. Cool. So let's look at a more kind of generic ring design to kind of get a sense of what the workflow is for taking kind of a popular commercial jewelry design and making it in Blender without, like we said, having pre-made features like prongs or stone holes. So let's load in one. We have here, this used to be the sample part for one of our jewelry resins. The split shank ring. It can be useful to just look at these and analyze how it was created. So it looks like we have a couple of sort of diverging shanks here. And then on the crown, this looks like it's almost a separate object. These are probably unions. Actually, they weren't. So when this was created, these were actually created as sort of separate components that were then basically sort of stacked together in a 3D space without joining them. And that's a totally valid strategy in Blender. When you're 3D printing something, you can just overlay stuff, and the preform software will basically take care of that. It doesn't need necessarily for you to join everything before you export it to preform, for example, or whatever your print planning software is. So let's look at how we might create something like this in Blender. I'm going to move this over to the side. So we want to have two sort of divergent pieces, and then this top part. This is actually quite a similar object, similar to what we were doing before. I'm going to create a circle, and I'm going to scale it to, let's say, 20 millimeters. So I think this is going to be a 20 millimeter circle. You can see here in the dimensions panel. I'm going to give it a subdivision surface, which is essential for making shapes like this. We're going to look at how large this is on the side. So this looks like it's going to be roughly 2 millimeters wide. Now we have this band, which I created by taking an edge, taking the circle edge, and just extruding it. We want to give it some thickness. We can do it the way I was doing it before, which is just extruding and then shrinking. We can also take this and add a solidify modifier. And solidify is very similar to the other operation, but it's just non-destructive. So we take that and we can give something a thickness. And that won't actually apply until we want it to. So I'm going to give that a thickness and then actually move the solidify before the subdivision. So the subdivision will smooth the solidify. And the solidify will be negative 1.5 and maybe 1.2. Negative 1.2. And here we can actually see that this ring has two kind of overlaid bands here. Let's see how we'll accomplish that. Probably what we want to do is just create one side of this and then mirror it over to the other side. So let's just take this top edge like that, and move it over. And if I just move this over, it will create kind of a smoothed motion, but it's not really what I want. So I can actually take this and enable proportional editing, and then go to, let's see, is that not really sharp exactly? It's somewhat sharp, but it's not totally sharp. And then this will allow me to grab more than what I just selected in this sort of radius. So we'll move over. I'll do that and just grab a little more. Now we have slightly curved band there. And it's actually curved out here too. I'll grab this and just make that a little bit curved, like so. If we take this and we give it just another loop in the middle, what we'll do is we'll start to give it a bit less of a curved shape. We'll give it a more of a square shape, similar to if I took these edges and I sharpened them just like that. But I want to just give it a smooth shape for now. And then we'll take this and we'll make a mirror, which is also another non-destructive modifier. And now we have this nice kind of diverging band here. And actually, we can take this and just use it for the same or for the next piece, which is these vertical numbers here. And I'm going to take this and just delete this side. Oops. Let's take this. Let's delete that side. Maybe even delete down to about here. I'll take this top edge here and just move it up, just like I did before. And add a mirror to the other side. And now we have these diverging top numbers. I'm going to add a little crease here. You can see that this has been sort of sharpened. Most likely this was created with a very similar technique. And now these want to be moved in. Disable proportional editing, but I can just slide this over to just the top part of the sharpness instead of all of it. So I'm just making all of it sharper, sort of poking at the side. Now we can add our top piece. So kind of a summary is this is constructed out of these separate overlaid pieces of geometry, but they're actually each quite simple. So when you look at this model, it's like, oh, it's kind of complicated in its form, but it's really not that complex a shape. It's just made of basic shapes that have been stacked on top of one another. So to make this top part, it's actually a bit square. So I want to add a circle, add a square rather, like a plane, make it large, and then add a subdivision to it. When you subdivide a square, it doesn't make a perfect circle. It makes a shape actually kind of similar to this one. We will add a couple of intermediate subdivisions. Now we'll get to even more of this squircle shape, and just bring those in by sort of shrinking them and scaling them relative to each other by hitting S, just scaling them. And now we have a shape that's like that at the top. And if we extrude this downwards, maybe about now when you're creating extrudes like this, if you have a specific dimension in mind for this, let's say we need this to be exactly 1 millimeter, you can press extrude and then just move things on a specific axis, a specific amount, so that we can just move this down in this right panel here by a numerical amount. And that definitely appeals to people coming from other software, understandably. In some cases, I like to just kind of eyeball it, but it really depends on what the constraints and requirements of your project are. Does it need a very sort of specific dimensionality to it. And then finally, let's just take these and take these and take these and inset them. So I don't know where inset is in the program, but I know that there's a function called inset. So I hit space and search for it, and inset faces, I think. It's a polygon. Yeah, it's inset polygon. So then we can just take these and just inset them to make this kind of inset ring. And we want to take these guys that are created and create a bridge between them. And now we have something that's kind of similar to that piece here. Let's give this a crease. It's sort of darker than the rest of the model. That's because the normals of the model, so the surface direction of the model has accidentally gotten flipped. And we can just flip that back over here, flip direction. And now if we take these and add a couple of spaces to them, make these sharp, make this pull down, the gap. This is, can be tweaked a little bit to be more similar if we want to, but it's not essential right now. Cool. So we have something that's kind of similar. We can take this and go along this edge with a hole pattern that we decide we like. We could create that procedurally, or we could create that by placing each individual one if we wanted less of a pattern. I'll just show you how to do it procedurally. If we make a curve, let's say we want to we want to take this curve right here, and we want to make a pattern that goes along that curve. So that's right now, it's not a curve object, it's actually what's called a mesh object. There's different types of objects in Blender. Meshes are sets of points and lines and surfaces. Curves are basically Bezier curves, so we can actually convert into a curve from mesh. And now we want to add just again a cylinder for the stone hole. Quite enough space for the stone hole too. Find that other one in the background, and we're going to move this to here. Offset it. And create an array, create a curve modifier, and just array these around. So the operations to do those are pretty quick, even though you don't have that explicit functionality. So yeah, that's kind of how you might approach making something like that. It's basically creating simple forms, extruding them, moving them around. The sort of underlying shape of the object is defined by the the complexity of the geometry here. It can be adjusted through the modifier stack. So if you wanted to make a simpler object and then subdivide it, you'd have fewer control points to move around. But fundamentally, as long as these modifier stacks stay sort of unapplied, when you apply them like that, it sort of bakes it into the model. Then, let's see that. Now it's bakes this geometry into the model. Right, keep it unapplied and then back for a second. Do a couple of Command Z's. Now the model is still editable in this way by the subdivision. So that's kind of the essential workflow in Blender. Let's open up another model here, the flower earring. So the flower earring is, oops, open, flower earring. So the flower earring, this is the model that I made from that sketch I showed you guys earlier. And this is created with a very similar process. Looking at that model, so let's look at the sketch for a second here. Open. So this is the sketch. So we can look at the sketch and say, well, there's a curve here. There's these leaves, and then there's the flower head. This curve is basically, it looks very similar to a Bezier curve. So we can create a Bezier that defines that shape, and then make sort of a swept curve following it. The leaves are curved, but they're basically hard-edged objects, and then the flower is a little bit more organic. But all of these can be made with the subdivision tools. So if we go back to the 3D view, we can see this center object is, I'll hide the rest of it. The center object is a Bezier curve, so we can move that around and adjust it in the typical Bezier fashion that you're probably familiar with if you're coming from Rhino. The same is true with these sort of leaf branches, and then the leaf petals themselves are actually, we hide everything else. Leaf petals themselves are actually just, I'll go to the modifier stack and show you how they're created. They're actually just simple planes that have been subdivided, and we move the shape around to be leaf shaped. And then once we have a shape that we like, so sort of I can demo how that could be done. Let's see, subdivide, smooth, subdivide, smooth. Add some more smooth. So the smooths that are available in this menu are actually not the same as the smooths that are available in the modifier stack. These are more sort of instantaneously applied rather than non-destructive. If we take these, we can move them around and start to create a leaf shape just by dragging and creating the shape like that. We'll take this edge that we can select it. It's an edge loop. Grab it, move it down, and voila, we basically have the same shape. So it looks like kind of a complex shape, but it really can be made in almost seconds. And then if we take this and we make a separate object, we take this and we solidify this. This has all the modifiers from the other one. We take this and we solidify it. We can give it some thickness, which is one operation. And then we give it a subdivision, which is another operation. Now we have sort of a thicker shape. But a leaf doesn't really look like this, and if you were casting this part, you want it to have kind of thin edges. So we really want the solidify to only happen kind of in the middle, and then it wants to taper out to the edges. So we can just select these, and we can start to define where that solidify happens. by assigning groups to the model. So those are groups that are created of vertices, and then only applying the subdivision to specific groups. Or the solidified specific groups. There we go. So now we have a shape that's only getting thickness in the middle where we want it to be giving thickness. And then maybe that needs a couple more subdivision. Playing with those shapes gets you really close to where you want, and then you can, the rest of the process is just sort of refining by adjusting this interior cage that you can see here to the extent that you want it to be adjusted. Let's see if you have any questions. Yeah. You have a pretty high proficiency. How long have you been working with it? About 10 years, but I think you really don't need 10 years of proficiency to get to a strong level. Blender has a ton of functionality that's really totally irrelevant to jewelry making and jewelry design. Like I come from Blender from the computer graphics world, where it's used to render CGI for special effects and movies and that kind of thing, which actually gives you, as part of this sort of incredible bundle with a pretty incredible value, it gives you a render engine that can render out your designs in a really fantastically high quality. But many of the much of the functionality is actually it's not useful. So it has animation and that kind of stuff that you can basically ignore. So I can show you a lot of jewelers are interested in the rendering side because it gives them the ability to show a design without having to basically having to cast it yet. So let's take a look at. This is a model of the new Formlabs castable resin sample part. But I think one interesting thing that we can show here is the ability to take a design and really just visualize it almost in real time. So this is being rendered on my computer, and you can actually get a pretty amazingly high quality of visualization output. Just from a few seconds of waiting. So the kind of link between Blender and the computer graphics world really gives it some of that that extra functionality that you can use if you like to do that, but you can also ignore it. Cool. Yeah, we have a couple more minutes. There are a couple other things that there's a lot more I could talk about. And, feel free to email me if you have questions or want to know about anything in particular. I think one thing that's really awesome about Blender is the world of extensions that it has. So people write scripts and extra sort of bolt-ons that give it functionality that you would have as part of the core program. So I can show you some of those. For example, so for example, one extension is, if you want to create pre-made gemstones, it has some functionality for that. It's not going to give you every single type of gemstone for a lot of basic types, you can adjust many of the parameters of your gem just by measuring it and then inputting, for example, how wide is it? If it's 2, and then you want to make this wider and taller, so you can kind of parametrically adjust what gems you want. That gives you the ability to size parts of your design a little bit more accurately than you would if you didn't have that. Another really cool one that I want to mention is the 3D print toolbox. So there's a whole set of tools. Unless I don't think it's enabled here, so I'll just enable it really quickly. 3D print toolbox. What is it? Okay. I should just select an object. So if I select this object here, let's say this one, and go to 3D print, you can actually check any object for 3D printability. So you can look at it and it'll tell you whether or not the model that you created is sort of valid for 3D printing. A lot of print processing software will give you much of that automatic cleanup for free or automatically. But this gives you, sometimes that automatic process can be a little bit prone to error. So you can do some of the checks that you would do on a model to just make sure that, for example, your model is manifold. So a manifold model is where it's fully enclosed. So now this model, we can check, for example, check all. Make this larger. It says non-manifold edge is 0. So it looks like this model is totally fine for 3D printing because all of these checks are at 0, which is a really cool, useful tool. You can also scale to a particular volume. So if you have a model and you want it to be exactly a particular volume of metal, you can just select the whole thing and then scale to volume, and that's and set it to a known volume. It should be within pretty close to that volume. Otherwise, you're going to scale the dimensions of your model and really don't want to. But if you're just a little bit off and you want to make sure that you are exactly where you want to be, you can scale the volume. Yeah, so that's a quick overview of Blender. Thanks for listening to me talk to you guys for a bit. Again, I'm really happy that you came, and if you really have any questions or want to just talk and show me what you're making or ask for feedback, I'm really happy to help. So yeah, give me an email if you want. And again, later on in the month we'll have further demo sessions from experts on other software, more jewelry specific software in some cases. Rhino Tinkercad is an interesting one, kind of similar to Blender in that it's less jewelry specific, but it's more about making very explicit definitions of how the model is shaped, rather than where Blender is, the operational mode is you're creating objects and you can define very explicit dimensions, but really their relation to each other is a little bit less well-defined. And that helps you have a little bit more design freedom and make stuff faster. But if you want to make something by kind of doing it in the traditional CAD method, Tinkercad is really cool, and it's totally free again, which is really cool these days for people who are interested in getting in without any price of entry. ZBrush is really cool. I wish I had time to talk about sculpting. ZBrush is basically the industry standard for sculpting software. Sculpting is basically a similar metaphor to real life sculpting. So if you're a wax sculptor, for example, you might really like ZBrush, or even the sculpting functionality in Blender, which it has. The sculpting is where you're pushing and pulling material as if it's clay, basically. So there, it's even harder to make very dimensionally specific models, but you get way more design freedom to make all sorts of crazy shapes. And then 3 design is sort of the most, I would say, jewelry specific software, and that'll be either at the end of the month or in July. So hopefully you can attend those, and yeah, thanks for stopping by. If you have any questions, I'm actually, I don't have any extra or anywhere to go for the next half hour. So if you want to stick around and ask questions, I'll be here. See in the chat. Oh yeah, so let's see. We have actually all sorts of comments in the chat, which I missed. Sorry guys. Is it possible to load a 3D scan and manipulate it? Yes, absolutely. So the 3D scan, oh, and sorry, I'll just mention the Jewelcraft add-on that Brian mentioned. I tested it out. I used to use that, and I tested it out this morning. It seems like it hasn't been up to date, hasn't been updated since like 2016. So it doesn't actually work with the newer versions of Blender, unfortunately. So I was pretty disappointed to see that. But if you wanted to roll back to an earlier version, you could use that, and then it would give you some of those more jewelry specific tools. But yeah, so Janet, loading a 3D scan. So Blender is really awesome at handling really high density models. So if 3D scans come in with, basically can be millions of triangles, and you need to process them. So actually, maybe I'll find a scan here. Let's see. It's quite hard to find anything in Windows for me. Scan. We have a scanner. Office. And I use it to scan things, especially scanning gemstones. It's really useful for this. Searching my hard drive for scan files. Well, it might not be something to do online, but yeah, so you can load them in. Typically, scan files come in with a lot of parts missing, so they need to be cleaned up, depending on what you want to do with them. Usually, what I like to do is use the scanner as kind of the first step in design, so you can scan like large clay models. You can scan existing jewelry to some extent, although jewelry tends to be on the smaller end of what most scanners can deal with. So there are jewelry specific scanners that can handle really tiny models. And you can scan them in and either use that as kind of a way to replicate parts, or if you scan something larger, you can add motifs to designs by just scanning them and shrinking them down and then remodeling around them. Let's see. Maybe I have a scan I can show. I search. Stone scan. Here we go. I think I found a scan of some opal. Let's see what's here. So here, yeah. So I scanned actually some little opals that I have. They came in like this. So if we, hopefully you guys can still see my screen. Yeah, I can still screen search. So these are these opals. They're jumping around like snapping on, but they look like this because they're stuck onto a little piece of clay. So we actually can't see the bottom, but the bottom of the opal is coated, so it doesn't really matter. What we mostly care about is just this kind of edge, this edge boundary, and making kind of a cup that holds the stone. And that's something that we can do really easily in Blender. So I can show you what that might look like. Let's see. What I just did is create a rectangle. Really, I just want a point that I can use to start a model. I'm taking the point, and then I want to snap to the edge. Snap to this edge, and then I'm going to delete the rest of them. And I'll take this and make a line, and then start to just go around and make a boundary ring that encompasses the whole perimeter of the stone. I have this boundary ring, and what I was just doing there is extruding and snapping. So you can just take it and just snap it on there, and now it flips. And when you click and hold control, it just snaps onto whatever model you're looking at. So I snap those on there, and clean them up a little bit. Everything is around, and now we have a ring. I'm going to add some subdivision there, make it smooth. And I'm going to add another modifier, which is shrink wrap. So that will actually take the shape and just shrink wrap it to this as close as you can get. And look at that. Now we have a sort of tuck that holds the part, holds the scanned stone, which is really cool. I'm going to take that, I'm going to just extrude it downwards. That. And right now it's just with this shrink wrap modifier on, all of these points that I created when I extruded this edge are just snapping directly to the stone, or they're snapping to wherever on this model is closest. I'm taking this, they're snapping automatically. I'm just going to add a solidify to it. Solidify like that. And make this sharp. And, you can finesse this to a greater or lesser degree, but now we have a shape that can hold that precisely. You probably want to extend the edge here, but that's how you can manipulate scans. I think that's fairly useful. You can also, if you have a gemstone, you can place it in a model like this and just size these prongs, accordingly, basically, or if you had a large sculpted motif that you want to apply to a surface, you could just put it onto a surface like this. There are all sorts of things you can do. Are we going to be recording the demos? Yeah, I think we are going to be recording the demos, definitely. Photogrammetry works pretty well for small gemstones. That's cool. Yeah, from my own experience trying photogrammetry, it's been pretty difficult. But yeah, if you have gotten to work, that's awesome. I mean, I know photogrammetry can be very precise. It just getting a great scan seems to depend on rotating either your model or the camera in a really regular way. So if you have a setup to do that with a turntable, you can do that. Also, if you're scanning gemstones, obviously they're transparent objects, so you need to typically coat them with some kind of scan spray or foot powder works really well, top powder works really well, and that will just map the stone so that so you're not getting any reflections off of the stone, which will screw up your scan. Fantastic. Awesome, guys. Yeah, so for the next half an hour, I'm going to just be modeling on here and talking through it. You can stay if you want. Yeah, thanks again for watching. I'm going to look at this filigree bracelet. This is a model that I made as a kind of demonstration of filigree design jewelry, which is when you're talking about 3D printing, it's something that can really only be done with a SLA or resin printer, because you're creating these really fine wires. You could solder them together with wire, but it would take incredibly long time. So being able to design it in sort of one fell swoop and print it is a really awesome advantage of both 3D printing and the ability to just create all sorts of different design manipulations on the surface really, really quickly. So let's see. This is kind of the base shape that I was using to create shapes for this bangle here. And you can see on the right here we have this modifier stack that's actually relatively complex, but if we break it down, what it's doing is the subdivision is happening, so that's giving it its sort of so we turn off all the subdivisions. So that's just giving it and some geometry to work with. The basic geometry underneath is actually pretty minimal. It's giving it some smoothness, and then we're doing these deforms. So deform is actually a really, really interesting modifier, and what it does is it starts to let you just adjust things based on mathematical formula. So the deform, the bend is happening, which is sort of a formula that causes a sort of angular bend in your model across the entire thing. So I turn this all the way down. Let's see, all the way down. I'm going to turn off the first one. We have lots of other ones, so turn all these down. A lot of them enabled. That's the basic form of the model, right? It's just a ring, right? So that's pretty different than this shape. But by starting to do these sets of deforms like this, we're starting to just like wrap it around, and then we're starting to curl it in this one, and then starting to, like, this one just wraps the whole thing over itself, and that gives you a nice bangle shape, I thought. And then what else have we done? We've turned on, no, we haven't turned on wireframe. You could turn on wireframe, which is, it does this, it creates like wires around the whole object. That's kind of a cool effect. I didn't like that so much, I turned it off. We did turn on triangulate, and triangulate is very interesting because it actually changes the shape of the underlying geometry. Let's see if we can show it somehow. I can turn on so you can see the wireframe. So when I turn on the wireframe, they actually, or when I turn on the triangulate rather, it goes from being this regular grid to being this sort of hexagonal grid, which is called a dual mesh. And that's actually the start of some pretty interesting geometry when you start to subdivide it, like we've done here. So I took that and, let's see, gone over to this one. So now we have, let's turn all of them off. It's kind of interesting to play with this and just turn off all the modifiers and see what you're working with. So this is the basic shape that we started with, back here, potentially a little different, but mainly the same. Basic sort of, not exactly a Mobius, but like just a band, and then we're turning on the subdivision, and we're turning on the triangulate to give us that kind of, I'll show you the geometry underneath, like showing the wireframe. So when we add the triangulate, it sort of gives us this dual mesh, which is like each one of the rectangles is split, but it does it in this interesting pattern. And then we can subdivide it again, and then triangulate it again. That gives us even more interesting geometry. And then we subdivide it again, and then go into wireframe, and suddenly we have this very interesting, almost mosaic pattern. If we displace it, we can give it a little bit of thickness. And that's really it. That's the pattern that we use. So we get this very interesting shape, but just through a few manipulations of this modifier, changing the geometry, and it sort of tiles very nicely over the surface. So in this way, you're getting kind of a similar procedural shape generation that you might be from something like Grasshopper, just through the modifier stack, which is really, really cool. And then we take it here and we just added this rim to it, and then that's the model. So yeah, that's kind of an interesting procedure for how to use it. What else have we got? 15 more minutes. Class ring. This is something that people typically want to do with 3D printing because it's a natural fit for 3D printing is creating customized jewelry. So how do we make something that's like totally a customized class ring? You know, we have unique text. We have a unique centerpiece here. So how do we make this model? Let's see. So the actual underlying model is very similar to what we were doing before with just making circles and then joining them. We have circles, and then we flatten them out like I did in that initial model. We flatten that out the top. And then this sort of hole here, you could do it by taking another object and just punching it out. But what I like to do, it's kind of an interesting technique, is just to take the model and grab some geometry like that, and grab some on the other side, like that, and then do a bridge and add something in the middle of it, just like that. And suddenly we have this like hole here, make sharper. It's a really cool way to sort of add perforations to models. I don't like that as much as the original one. Do it. And then the top part is actually a separate object. Once again, we're dealing with this technique of just taking shapes and layering them on top of one another. They don't need to be Boolean joined. They don't need to be merged. They're sort of floating on, floating together, and that gives you a lot more freedom to adjust what you're working with. Like if you look at this model, this ring here, it's a fairly complex design, but really each of these components, each of these subcomponents here, is just its own unique little design element. And individually they're not that interesting. If we look at this, they are. This is mirrored, so it's disable mirroring. Look what this is. It's like a curve and another curve. And we have a crease here. That's like making something sharper. And we made it solid. So let's make it unsolid. Like that's the shape. That's really the basic shape. It's really simple. But suddenly when you add some of these extra sort of extra modifiers, it makes something that's very interesting. And especially when you get into a case where you start to play with how the subdivision like moves next to itself. Like if we move this edge and we move it closer, it sort of creates a crease there, which is a really interesting effect of that. You can see what it does to the other side. It does something unique to the other side as well. So we can create a bit of relief just by taking a central edge. And this is how it was originally. Basically, without the solidify, it was like that, And then I added a couple of these, a couple extra edges here. Add a solidify. Take one of these, maybe add another one. Take it and just move it in, and I have this image. So that's how the entire model is created. It's very, very fast to do this kind of thing. And you really, especially if you're starting from a sketch, there's no better way, in my view, to just quickly draw out the shape and then start pushing and pulling the edges and the vertices to make something that's that feels interesting or a little bit more alive. The mill grain here on the edge is actually, I wasn't sure if it was an array, but it's not an array. It's really just like a ring where each of these little sort of each one of the lines that constitutes the ring has been extended outwards. So you can do the operation for you if you're curious. and take each one of these and just, let's see, extrude individual and move. So now we extrude the individual and move it a little bit. And then we can take each individual one and scale it. There's a little button here that lets you change where things are scaled to. You can scale them on individual origins. Oops, I missed the one. Oh, it doesn't have to scale individual. Extrude individual. Extrude individual. Only edges and remove. I don't know why it's not doing that. Well, there is a way to take each one of these and just move them out and then scale each one of them individually. Essentially like this, and then scale it down, and then you have a little nub that comes out. And you do that all around it, and you have something that can exist inside this edge, but it exists as nubbed because only the little mill-grain protrusions are poking out inside. Yeah, so going back to the class ring for a second. So I was thinking, maybe you want to have like a ring showing that you are you have a positive test for coronavirus antibodies. It signifies that you're free to work and move around. So we have a ring that has this text, and text is also really quite simple. Text is a type of object in Blender, so you can create, similar to how you add a mesh, or add a curve or add a surface, you can add text. And then the actual text can still be edited, even though it's even though it has a curve applied to it. And then when it's in this case, it's being actually, because this rim has a slight curve to it, or a slight downward slope. So we don't want a text that just comes straight down. We want text that comes at an angle. So if we can create a shrink wrap that sort of affixes it to the surface, and then solidifies what gives it just that emboss. So that's a really easy thing to add. It can be a little bit. Whoops, I made a Z there. It can be a little bit tricky, because if you create text like this, it's common that you'll end up with quite sharp sort of areas between the emboss, and that can actually be problematic when you're casting in resin. You're printing your parts and casting them. So if you want to take those, you can give them a little bit of a sort of stress relief in the casting process, just by taking them and see where's that whole. I'll show you in this. Gets a little complicated if there's. So you can give them a little bit of bevel depth, and that will sort of take the strain off, because it's at an angle rather than straight down. Yeah, and then what to do about the middle? The middle is its own empty spot here. So one really cool way to, and we talked about this in a ZBrush webinar, but one really cool way to add interest or add motifs that you can really quickly do in Blender is take take a shape or take a surface and then what's called displacing it with a image that basically encodes vertical height information. So this right now is just a flat plane that has actually been subdivided a lot. You can see it's been subdivided a huge amount. So it actually has a lot of geometry in there, but it looks flat. We take this and then we unwrap it. So unwrapping it, what that does is, take a second here. What unwrapping it does is it sort of creates a map of projection, like a map of the Earth of the surface, and that lets you apply. Really, you should unwrap before you subdivide it to a lot of geometry. So I think Blender might be crashed right now. Sorry for the difficulties, guys. Hold on. Oh yeah. Great TV. I'll open it back up. So yeah, now I've unwrapped it. I did the wrong unwrap option. If we look at our image editor, now we have the plane just unwrapped here. And let's say we want to have a like an embossed area here, like an embossed region with an image or with a kind of bas relief. We can take there's a modifier for that. So we go into the modifier stack and we go down to this place and we create a texture. And the texture will have a so we'll have this texture. It's not really as appropriate. It's like a little horse guy. So you could do something like that. Just instantly create a relief. This image is what's called an alpha. So you can look online and find alphas. You can also create alphas from almost any 3D models. If you have a model, you can create like a sort of 2.5D relief from it that doesn't have any undercuts. It's just like comes straight out of your model, and it's mostly flat, but it gives you a bit of sort of textural relief. So let's see, I created there's actually a blend file that I can share, which generates these reliefs. So I created one that is gives you all the instructions for how to do this. So let's import a little coronavirus, import a model that I found on the CTC website for the center of our ring. Load in here. Load in and follow the instructions to make sure that this is in the right spot. This Blender pane looks different because we've created all these like dynamic, movable viewports and stuff, but really it's not. It's the same program. We've just like split out the viewport in a lot of ways. It could be brought back to its normal state quite easily. Give this just a little bit of depth here. Right. Okay. Render it. What I'm doing is I'm sort of pulling out the depth information from this model to give me the ability to make an image like this where it encodes just the the 2.5D just depth information of the image. So do that, we wait for it to load, and then we go here. Save a copy here. All that. Now we will open Classroom. Do that displace again. Texture for displace. Open our image and make sure it's mapped correctly onto the object. Change the mapping by filling this. Yeah, now we have this like cool sort of 2.5D relief of coronavirus virion in the middle of our positive antigen classroom for 2020. So thanks guys again for watching. Really appreciate it. Would love to answer any questions. Feel free to send them along, and have a great day.